Good morning, ladies and gentlemen. Welcome to the video on periodic behaviour. Once again, I apologise, my pen does not work. Here we're going to start looking at what will become trig graphs. But in the start, initially, we're going to use a little bit of language here and just look at what we mean by periodic behaviour. Periodic behaviour for us is one-note freezing because it happens periodically. We're good. Is something that varies throughout the year. So one example might be temperature. We can expect temperature to peak in December, January, and to hit a trough around winter, July, August. And that will go up and down throughout the year. So over a 2-year period or 24 months, we can expect 2 peaks, 2 summers, 2 troughs. Alright, key vocab. Okay, so key vocab, there is a principal axis or a mean line, which we can get by doing the maximum value plus the minimum value divided by 2. And that's the line that the rest of the wave, if you like, oscillates around. And we do refer to this in terms of a wave. And so much so that we use some wavy terms. So a maximum point occurs at the top of a crest. That will be the max there. Or a minimum point at the bottom of a trough, or the nadir. Good word, nadir of a trough. The amplitude is the distance between the maximum and the minimum. So it's max minus min divided by 2. So amplitude is this gap here. So you can either think about it as the distance between the max and min divided by 2, or the distance between a max and the principal axis, or the min and the principal axis. Alright, so typical question might look as follows. We're given a set of data with time and height above ground, in this case, of a point on the bicycle wheel. And quite often we're given sets of data. This could well be time and temperature for years in the month, or any other combination, and we were asked to plot the data on a graph. Now we could go through laboriously plotting, alright, time equals to 0, it was 0 above the ground, so 0. At time equals to 0.2, it was 6 centimeters above the ground. And there's another point. And go on and on and on. But plotting all of those points, while I'm sure you could do it by hand, would take time. This is why we have the calculator. So calculator, you can go into statistics mode, number 2. And down one list, you can enter all the values you want on the x-axis. To make things easy, we put all the values on the x-axis in list 1. List 2 has the y-axis. And then you go, of the options down here, you want to create a graph. So you click graph. Now, first thing to do is click set. There's different graph types. Scatter is what we want, because we want to create a scatter plot, lots of different dots. The x list is list 1, y list is list 2. Makes some sense. And we can set that. If you have those settings there and you click graph 1, it means that that becomes graph 1. You can't see me clicking it, but I am. Alright, then we hit graph 1. And that there is our graph. Is it reasonable to fit a curve to this data, or should we leave it as discrete points? Yes, it's reasonable to fit a curve to the data. They move very smoothly, and we can imagine the data, well, we can imagine going through there with a curve. Now, is the data periodic? If so, estimate the equation of the principal axis. Well, that's hard to do given we can't see a scale there. If we put it in an Excel spreadsheet, we will be able to see a scale and estimate from the scale. But the other way to estimate the equation of the principal axes is to look at the maximums, look at the minimums, and note the gap between them. The gap between them is about 62 to 64. And remember, we're only estimating here, so I'm going to call it, well, 62. Anywhere between 62, 63, 64 get you the mark. And the equation of the principal axis is going to be halfway between the minimum and the maximum, between 0 and 64. And it's an equation, so we're thinking here that would be y is equal to 31. That there is 0 plus 62 divided by 2. Right. What is the maximum value? Well, about 63, 64. So we could estimate that as 63.5 if we want to take the average between them, or anywhere between 63 and 64 would get you the mark. That was going to be a 64. What is the period? Now, period here is how often something occurs, how periodically it occurs. So here, annually might be the case with seasons. A good way to look at it is the gap between minimums and the gap between maximums. So here, if we look at the gap between the minimums, there is first minimum at 0 and the second minimum at 2 seconds in. The gap between the maximums is 1 second in and 3 seconds in. So essentially the same points on the graph repeat every 2 seconds. The period, therefore, is 2 seconds. The amplitude is the gap between the minimum and the principal axes, or the maximum and the principal axes. In this particular case, we'd say it would be equal to the equation of the principal axes. So the amplitude here is 31. Now, this you won't have to do yet, but on the graph, we can actually plot a curve through that. So these are all different types of equations on the list here. If you go across, we can ask it to plot a sine curve and ask it to draw it. And you note that a sine curve fits almost perfectly. And what we will be learning is what each of these parts do, A, B, C, and D, in terms of creating the sine curve. For example, A, I can tell you, is the amplitude. So our guess of 31 is pretty good. The actual amplitude is 31.24. D is the principal axis. So my guess of 31 for the principal axis is not so great. It actually should be 32.5. But we'll look at more about where those letters came from in a future recording. For now, it is sufficient for you to be comfortable with those concepts there. Thank you very much.